So, welcome everyone to the Monero Chicago Meetup. So I'm Skylent, I'm the guy who makes the memes on Twitter, but we're all going to network, we all have skills and things that we want to talk about. But specifically today though, we actually have a couple presentations that I think you guys are going to have a lot of fun with. But firstly though, our beloved leader has some words that he wants to say, so please welcome on the stage.
All right, that's enough. That's it. Speech. So here's the speech. Yeah, my name is Vic Sharma. I'm the founder of Cake Wallet, and I thought I should at least let you guys know how I ended up with the Monero Chicago Meetup. Yeah. So I run the Monero New York Meetup group, and Meetup reached out and said, "Hey, this group is abandoned. There's nobody, so I had to step in and take care of you guys." So which was good. Justin was already in Chicago, and we thought, hey, why not? We've been doing these meetups in New York for 6 years now, and we thought, okay, let's start doing it in another city. And Chicago, I think, is an important city and very active in the crypto space. And we thought, okay, let's do this and introduce and have more detailed discussions about Monero in Chicago. So, quick intro about me. Can you guys still hear me?
Yep.
I hate standing behind a podium. So I got into, like I think many of you, I got into Bitcoin, pretty early on back in 2013. I actually thought I got into it late, as I got on too late in 2013. And then started mining Bitcoin, I read about Bitcoin, it just clicked. I was like, this is huge, this is gonna be awesome. So I just dove right in, started mining Bitcoin, started just, open a Coinbase account and started just buying every day, wake up in the morning, have coffee and buy Bitcoin. That was my morning, And it was great. Then after about, 2-3 years, I thought, okay, I've been collecting, I've been mining, I want to do something with my Bitcoin. So I went on the dark web. Who's been on the dark web? Nobody's hoping you actually. We'll cut that out of the recording. So I was like, okay, and I bought antibiotics. My wife needed antibiotics, and she's like, I don't feel like going to a doctor. I'm like, I know where to get it. And so I got on. There was I don't know if you guys remember. There's something called Alphabay, the darknet market, and I bought antibiotics, and I sent Bitcoin from my Coinbase account directly to a darknet address. And back then, this was I think 2016, and I didn't understand chain analysis and tracking Bitcoin, and I thought it's like they're probably tracking like terrorists and massive drug dealers, not like somebody like me. And I sent the Bitcoin, and within, I swear to God, I pressed send from my Coinbase app, and within seconds, I got an email from Coinbase saying, we're shutting down your account, and just move your coins, and we don't want you anymore. You violated some terms of illicit use. So I thought, how do they know this? Like, what are they doing? They're tracking everything. Even a small guy like me, just sending like $25, they know how I'm spending it. So it's kind of disturbing, but then at the same time on Alphabay, there was another coin called Monero. And I was like, what is this? Not Litecoin, not Ethereum, not Dash, or whatever else was big in 2016. And I thought, well, why Monero? Like, just Bitcoin and Monero. So, like I did in 2013, went down the rabbit hole of Bitcoin. In 2016, I went down the rabbit hole of Monero. And just watching YouTube videos and everything, and how many of you guys already know about Monero? Or how many don't? Maybe that's a smaller number. Oh, you? Okay.
With my boyfriend.
So,
I'm trying though.
yeah, and there's people in this room that can talk about Monero way more technically than I can. But what I like about Monero is you too. Monero, you can hide it hides the sender's address, hides the receiver's address, and hides the amount that's transacted, right? And why is that interesting? besides just privacy, right? Why is that interesting? Privacy is number one. Number two is fungibility. I know that's a term Monero people like to throw around all the time, fungibility, but it's important. For example, would you accept Bitcoin that's traced back to a drug dealer? You probably would. Would you pay more for a Bitcoin that's owned by Elon Musk? Yeah, maybe some people would. Okay, I know you would. Some people would. Some people would. Would I pay more for a Bitcoin that was, I don't know, used by Taylor Swift or something, you know?
Oh, this girl would.
Yeah. And you'd be like, yeah, see this Bitcoin? Taylor Swift. You know, so you know, then you ask the questions, is every Bitcoin equal to every other Bitcoin? And that's a question that's debated all the time. So whereas Monero, you don't have to question that. You get a Monero and it's clean. I mean, one way you can argue that every Monero is dirty, but you know, so if it's all dirty, then it's all clean. The point is that one Monero is like any other Monero that's on the blockchain. So that's why I got into it, and I understood, you know, privacy and fungibility are two sides of the same coin. Okay, I'm gonna stop. So that's my speech, and you know, I already told you how I came to this group, which I'm really excited about, to, you know, get out of New York and come to a great city of Chicago. Just one last question: how many of you guys were already in this group before we took it over? Just two people. Okay, great. So yeah, you know, even though we're the organizers of this meetup, but you know, it's for everybody. So in the future, if you guys want to see more content or workshops or invite different types of speakers, you know, let us know. So this group is to educate everybody about Monero. So we've got great speakers for you here, which Skylink will introduce. But I just want to give a shout out to some interesting people in the crowd. One is Sarang, the shy guy with the beanie. So Sarang, for a long time, was officially and then kind of unofficially part of the Monero Research Lab. So the amazing innovation you see in Monero, in all the cryptography stuff, I'll be honest with you, I don't understand it, so you can talk to him and understand that. But from a user standpoint, amazing thing he was involved in and led the efforts of that. You know, many years ago, every Monero transaction would cost you like $2, which kind of made it difficult. Like, you know, everybody says, but can you buy coffee with it? So you couldn't buy coffee with Monero. And Sarang did the research and came up with something called bulletproofs, which lowered the transaction fees to less than a penny. I mean, it was insane. And he didn't promise that. He promised, you know, 20 cents, 30 cents. But then when it actually went live, it was less than a penny. So, and he reminded me yesterday, he's like, you know, I'm still contributing. I'm like, okay, so that's good. Another person in the crowd, we have a social media celebrity, Girl Gone Crypto. So, Cake Wallet, and can I use your real name? Or?
Yeah.
Oh, okay.
Yeah, that's fine.
You're not a real Monero person. Lana and Cake Wallet have worked on and off since the beginning, since we launched Cake Wallet, and just, I'll say a couple things I really liked that you did, which still stand out for me. One is, of course, the Monero video you did explaining how Monero works, which is really good. The other thing I think was hilarious was the, so this is Christmas song, and she did, so this is crypto. You should just look it up on YouTube, it's hilarious. All right, so good. So we're gonna have good speakers, then we're gonna do some trivia, then question and answers. A lot of brilliant people in here, Monero people, so if you wanna get into like deep cryptography discussion and debate and why Zcash is better, we can do that. So we can have those discussions. All right, good. So thanks a lot. Thanks for coming, everybody, and enjoy it. Yeah?
Okay, everybody, so our first speaker is going to be Justin Berman. We have a really awesome presentation for what I've seen so far on that, as well as from Luke, but first is Justin. And before that, I just want to say, guys, as we're hanging out, guys, we have a lot of pizza. So eat some pizza, drink some beer. We have a lot more in the back, too. We're going to be bringing that out. Get out of your skins. Come on. And we can talk about a little bit more than just Monero, too, as well. I know a lot of you guys are awesome with the futurology, talking about just science and tech in general. So I'm looking, as a social media guy, looking forward to that too. So I really need to learn from every single one of you in this room, but probably especially though, Justin Berman, come on up and do your little presentation. It's gonna be great.
Hello. Thank you. First, want to say thank you to Cake Wallet and to Vic for putting this on. This is it's a cool event. Getting together and talking Monero with people is it's amazing. This is life. So, okay. So I'm Justin Berman. I've been working on Monero full time for 2 to 2.5 years, and so I'm CCS funded. And so I'm going to be talking today about, I shouldn't mention it, but I'm going to be talking about my latest work on Monero, stuff I've been doing, go through 4 different things I've been focusing on. Sorry. Okay.
You're okay.
So, first one is background wallet syncing. So Cake actually just released a similar feature recently. The one that I've been working on is the ability to sync in the background without your spend key hot on your phone, so with just your view key. And so I'll get into what that means for any newbies out there today. And then also, so faster wallet syncing. So one of the biggest pain points of Monero for people who are new, who haven't used it, who don't use it very frequently, or if you have to restore your Monero seed, you can have to sit waiting for a wallet to sync for a while, and so been working on making that sync process faster. And then, so third is Luke gave a presentation at MoneroCon earlier this summer on full chain membership proofs as a replacement for Monero's ring signatures, and so I've started work on integrating, very tiny amount of work on that on my end so far. I'll talk about what I've gone into so far. And then fourth is Monero-only, which is also a library created by Luke, which can be used to construct Monero transactions and written in Rust, and talk about why that's useful and what I've been working on there. So, background wallet syncing. So, as mentioned earlier, so full wallets like Cake Wallet have to scan every transaction in the blockchain since you last opened it in order to identify the Monero that you've received and spent. And so this process takes time. And this is just one of the this is as a result of Monero's privacy component of stealth addresses, which hide the receiver in a transaction. This is just one of its introduced UX pain points. And so in Monero, there is also a private view key, which you can use to see all the Monero you've received in your wallet, and then you have a private spend key, which is used to spend the Monero you've received. So there's an idea proposed by Howard Chu, HYC, where wallets could just sync in the background on the phone or on your whatever device your wallet lives on with just this private view key. And so it could be safer to have this process running at all times or as often as possible without concern over leaking your spend key, which someone can use to steal your money. So that is the basic premise and idea of background syncing that I've been working on. And so I've gone through three big iterations of it. I've been working on it for a long time, actually. Unfortunately, it's taken quite a bit. So the first implementation, I made it so that you can only sync an already open wallet while it's idle. And so basically that means like you're using your wallet and you like close your phone or whatever, and the wallet is technically still open on your phone, and you just haven't opened the app in a while. It goes idle, and so it starts to background sync. That is how I initially implemented the feature. And it kicks the spend key out of memory, so it'll be syncing in the background. And it was initially implemented in a pretty complex way, which I won't get into the technical details of it. And then I started working on a separate fix to it, a totally unrelated bug, and in that fix, found a way to make this sync process a lot simpler, and so I then changed it again, overhauled it to make it simpler, and then most recently, so our Renee Brunner reviewed the PR for this simpler implementation and then proposed, hey, actually maybe we might want to implement this in a way where if the wallet shuts off, the closer, for example, you restart your phone and you reboot your phone, maybe we want the ability to be able to kick off this background sync process right away. And so the reason I didn't initially implement that is because technically that means you're giving access to your private view key to the device your wallet lives on into perpetuity. And so I figured maybe, I mean, that's doesn't sound so great, and so I didn't start off with that, and now I've since implemented both options. So, and also pushed from Justin from Cape Wallet to expose this option, because actually mobile phones provide some protections that make it a pretty solid approach. So this final version that is now out for review at the moment, I'd say, so the two options that you have of that, the background syncing while the phone is idle, or your wallet is idle, I would say this could fit well, theoretically, I think, with Cape Wallet's unobtrusive background syncing mode. If there are anyone who's explored the feature so far, I think it could potentially fit well there of not obtrusive, not going to push in however Cape decides to implement it, but basically it's not obtrusive. The wallet doesn't have access to the private view key until you open the wallet. And then there's the aggressive mode, which gives your phone basically full access to your private view key at all times. And so you could restart that background syncing process once you restart your phone. And so I basically pretty much explained how this already works. So the option one of once your wallet is idle, you haven't used it for a while, it has one major limitation to it, which I think Monero also encountered a similar limitation. So a lot of the times a phone, it's difficult to trust that it will keep a background process alive. Sometimes mobile phones will shut off background processes whenever like battery gets low or an app is using too much resources, it'll kill the process and you just don't have much control over what the OS does. Which means that with this option, this background syncing while idle only, if the phone does that, or if you restart your phone, it wouldn't be able to kick off the background syncing process again automatically. You'd have to reopen the wallet. That is unless the phone had perpetual access to a user's private spend key. So that's a caveat. So that's with this option. And so here I have, this is pulled directly from Cape Wallet's docs on the background syncing feature that goes into issues that they've encountered with the background sync process already and how various operating systems function, which can shut them off early. So I won't get too deep into it, but like one key point here is on Android, we've seen background tasks be permitted for as low as 5 seconds and as much as 600 seconds. And so, I mean, maybe you have your background syncing process going for 600 seconds and then it shuts off and now you don't use your wallet for like a couple weeks or whatever. You have to sync for that whole couple weeks. So it's a struggle to get that functioning nicely. And so now this second option of where you can basically give your wallet perpetual access to a user's private view key, with this option could now function smoothly, should be able to function smoothly in a way that even if the phone shuts off, you turn it back on, the background syncing process can rerun, and so the wallet can, in theory, stay synced perpetually, hopefully. So current status is that the PR is done, the code is ready, and feature complete. It has won approval from Renee Brunner, and I'm still working on the GUI implementation. And so that's basically where it's still, which would be a separate PR, but this is where it's at. So it's close. Should be right around the corner at this point. It's been a while. So next thing I'll talk about is faster wallet syncing, so making this process quicker. So many wallets in the Monero ecosystem, which includes Cape Wallet, reuse the code from the Monero core repository And that code has a syncing algorithm that is then reused in a lot of wallets across the ecosystem. And there's room for improvement in that algorithm. So Yuko HB, who, for anyone not familiar, keeping track, he has been working on Monero for a while, and he created Seraphis with his brainchild, and he, as part of his work on Seraphis, rewrote an entire wallet library from scratch. And that can hopefully replace what's called Wallet 2. So Wallet 2 is like this kind of beast of complexity that lives in the Monero core repository that has kind of built up quite a fair amount of technical debt over the years. And so by rewriting the wallet library from scratch, we're kind of able to get rid of this technical debt with a whole rewrite. And so while building off of this and working on that code, I implemented this new scanner using also another design that Co came up with, and right now it is clocking in at between 20 to 40% faster from my machine. So there's a lot of room on the table here to make it a lot faster. So, and I'll explain how. I'll get into some technical details here. So Wallet 2 today. So Wallet 2 is what pretty much, or almost most wallets use in order to sync the Monero blockchain. And so let's just assume that you're going to start scanning, if your phone starts scanning from block 5,000 in the blockchain. So like you have your seed, you created your Monero wallet at block 5,000, and so you want to restore it. So here's basically what Wallet 2 does. So the orange rectangles here is your phone downloading the blocks from the blockchain. So 5,000 to 6,000. And then it'll immediately start the scanning of those. So first it downloads the blocks, and then it scans every single transaction in those blocks to see which Monero is yours. And then in parallel, as it's doing that scanning, which it also does in a multi-threaded way, so it should be theoretically pretty fast. In parallel, it'll launch the next request for the next 1,000 blocks. So it's doing both at the same time. It'll scan the 1,000 blocks that it had just received, and then it'll submit the request to get the next 1,000 right at the same time. So this new asynchronous scanner, what it does that is different from Wallet 2 is that instead of just requesting 1,000 blocks, it'll request, depending on how many your thread count on your machine, it will request a group of blocks. So let's say the default is 10. So if I have 8 threads on my machine, and so it's set to start with 10, it will request 5,000 to 6,000, 6,000 to 7,000, all the way up to 14,000 to 15,000, all in parallel. And so as soon as one comes back and it receives it, it immediately starts scanning that also in parallel. And so that essentially is panning out pretty nicely, and the performance is benchmarked, or it's representing a pretty serious speed up. And this will get into, so that is like a simplified version of how it will work, but in reality, each of those requests is actually going to have variable time in their time to get to the wallet. And so you can see here, so for example, 5,000 to 6,000, let's say that takes a bit, but 6,000 to 7,000 comes in a lot quicker. It can just immediately start scanning, not have to sit waiting, which the prior approach had to do. And so that's how it works and functions. So some other technical highlights with this new scanner, just some nice features of it. So it will be backwards compatible with today's nodes, so no nodes will need to update or change in order for this scanner to function. And it works today also. I should clarify this too. This is not for Seraphis in particular. This is today's Monero. This works today. And to maximize performance, however, nodes would need a very small changes that are just very minimal. For example, one of them being the node has to say you can supply a max block count. And so if in the request you can say I just want 1,000 chunks with a max of, or 1,000 blocks with a max of 1,000, and the node will just give you a max of up to 1,000. That is one way that this scanner technically relies on to have it speed up, but it's a really small and simple change to the node. So that's a nice plus, easier to review, simpler, not a lot of added complexity on the node side to get this working. Another nice feature of it is that error cases, such as like a node going offline, for example, are the same as the, so Cake Wallet currently will reuses the code from Wallet 2, and it, like for these error cases, they get bubbled up into that the developers of Cake Wallet rely on in their software, and so the error cases are the same. And so it's not reinventing the wheel in that way, and there's just there'll be less work involved in getting it integrated. And then also a nice feature of it is that it's a modular component, and also you can bring your own network implementation, meaning that you're not if you're using Wallet 2 in your code, you're not accepting, you don't have to rely on Wallet 2's implementation for how it gets blocks from a daemon. You can bring your own and do it however you want. I mean, there will be a batteries included way of doing that, but it's written in a way that makes it easier to just, like Lego pieces, build how you need it to be built.
That is awesome.
Glad you think so. So this current status, I have got a work in progress PR. It's pretty rough, and I'm hoping that it can be ready for review within the next 3 weeks, give or take. And it wouldn't ship until the Seraphis library itself is ready, which could hopefully happens within the next year. I'm going to push to get things moving quicker. Hopefully it goes out sooner than that, but basically look out for that. So the next thing is full chain membership proof integration. So in Monero, today we use ring signatures to provide sender privacy. And so let's say I receive Monero on Tuesday, I go spend that Monero on Wednesday the next day. My wallet will construct a ring signature so that the Monero that I'm spending, that Monero that I received in the prior day, could be one of 16 other Monero outputs is what they're called today, and in Seraphis would be called e-notes. So I'm spending one of 16, and so anyone looking at the blockchain can't tell which one of 16 Monero outputs or e-notes I'm actually spending. With Seraphis, it's proposed to bump that up to 128, maybe higher. And then with full chain membership proofs, that number goes up to 1 out of millions plus, because it's all Monero that have been received in the past. And so it represents a pretty significant privacy enhancement to Monero currently. And so MoneroCon, Luke Parker, Kai Benerv goes by Kai Benerv, he presented trustless full chain membership proofs. So again, this doesn't rely on a trusted setup in any way. It's all it's completely trustless. So, and another point to Seraphis is that with the introduction, it would replace Monero's existing addresses. So your current address starts with a 4 or 8 for a sub-address. Seraphis would invalidate those, and after its hard fork goes into effect, you would have to start using a new address. And so the best performing, so far, the best performing full chain membership proofs would need an additional tweak to the Seraphis address that would be introduced. And so the goal, my goal is to get this as far as possible so that, basically as soon as possible, so that we don't end up in a situation where Seraphis launches and then we have to change addresses again, which is like a pretty painful thing to put the ecosystem through for everybody. So this is, so right now I'm exploring, working on integrating those full chain membership proofs that Luke implemented in the Monero code base. And so get into exactly what that entails. So Luke's implementation is written in Rust. The Monero code, for the most part, is written in C++ and some C. And so what that means is to use that implementation, we have to get that Rust piled into C++ to be able to call it from the C++ code. And so there are two methods, or rewrite it entirely, but there are some nice benefits to it being in Rust in that it offers some nice safety guarantees, and plus it's already in Rust, and so might as well just work on integrating it like this. So the two main approaches to get Rust code piled into C++ are C bindgen, I believe is how it's pronounced, and what that does, It'll just generate seed bindings from Rust code and has a bridge to call that code from it. And then CXX, which is the alternative path, offers some, it has a bit more limited scope in that you can't do certain things. It has stronger static analysis guarantees in it, there's stronger opinions on it, and also enables you to call C++ from the Rust side. So it has greater flexibility on that front. So that's why I made the decision to go for CXX. And so the current status is that is set up, CXX is functioning, able to call the full chain membership proof code, run the benchmarks from the Monero C++ code so far, and now it's just like a super high level, just run the benchmark test that Luke has already written. And so next up would be cleaning up the API so that from the Monero code we can call approve and a separate verify function, and then ultimately landing on being able to construct full chain membership proofs as part of Seraphis transactions. And that's the end state and goal with this work. So still to do on the full chain membership proof side is implementing generalized bullet proofs to replace the more Luke describes as the hacky vector commitment scheme that they initially created, and so that would be replacing that, and then it needs audits as well. So be a stronger academic vetting. So Monero-only is the fourth thing I've been working on. So Monero-only is it's Monero transaction library, so you can use it to create Monero transactions and also scan Monero and sync a Monero wallet. So it's written entirely in Rust again. That's a favorite from Luke and a lot of people. So as far as I know, every production wallet that I've seen so far relies on code that's written in the Monero core repository. What's very interesting about Monero-only is that it's written entirely from scratch. It doesn't rely on any of that code. You can construct a transaction entirely without relying on any code from the Monero core repository. And so because of this issue, because a lot of wallets do rely on core Monero code, there have been some issues that some wallet developers, not all, have encountered in the past. One of them being cross-platform support, so building the C++ code to work on all types of devices and machines. People have run into some issues there. And then also there is this belly of the beast underneath where this wallet 2, this massive technical debt is kind of growing in complexity and building up. And so another alternative here of a totally separately implemented from scratch Monero-only Rust library is a nice approach in that it can just sidestep that and it gives developers another option in the toolkit. More tools is good, I would say. And so it's got a nice streamlined API as well. It's a nice library. So one thing I've been working on is avoiding fingerprinting. So now, okay, so this separate library, ideally, I mean, you don't want to be able to tell that a transaction was created with Monero-only and be able to distinguish that from a transaction that was created with Cake Wallet, for example, or any other wallet out there. All Monero should be fungible. No one should be able to tell a difference between different Monero and where it came from and how it was created. And so this is called a fingerprint. If something sticks out that is identifiable as such as some distinct mechanism, we call it a fingerprint. And so the two areas that I've been focusing on to reduce the fingerprint surface are fees. So for example, let's say your wallet uses, fees are 2 cents today, and then some wallet, and there's this common algorithm that all wallets abide by and use to select the fee to land on the exact number that they land on. And so if another wallet implemented its own fee approach, and then, for example, the wallet would use 5-cent fees, that would be a fingerprint, and you'd be able to tell, oh, this wallet was the one that constructed this transaction. So I've been working on getting those fees to match the exact same as every other wallet that is reusing the core Monero code, and then the decoy selection algorithm, which is what's used to construct ring signatures to select that other Monero outputs across the blockchain to include as the decoys in your ring. if that were to stick out, that would be another way to fingerprint transactions. And so I've been working on both of those. And so the status, the fee PR is merged, and the decoy selection algorithm PR is still a work in progress. More testing, I'd say, is needed. I'm planning to test further and to review all the Monero-related code all the code in Monero-surveil, and then Luke also intends to have the library audited. So that is the status of Monero-surveil. Thank you very much.
I have a question.
Oh,
So sorry.
you,
No,
you wanted it.
no,
you wanted
Luke.
it. That was that.
Are you sure?
You got
Okay.
it.
So about the blockchain syncing, you know, it's pretty obvious when you open Cake Wallet or even the Monero Wallet CLI, there's a phenomena that I witness as a user where blocks come in and then blocks stop and then they come in chunks, right? And effectively what I feel like I saw in the slides that you were presenting is you were presenting that visually and showing a new way where I can possibly expect as a user to see a continuous trickle of blocks on an indicator rather than seeing it kind of in the chunked way that...
It's funny you say that because I have one of the to-dos on the PR. Actually, it's worse on this front, I will say. So as I've currently implemented it, because I can go back and show you from here why it's worse right now. But that's an open thing that I do want to make it smoother. It would be it's definitely not a great user experience
Sure.
to have to be stuck sitting for a while.
Sure. Well, and I mean, it's about the end result, right? So, I mean, if the net result is faster sync times, then that's a win, right? But I was curious because I saw that visual and I was like, oh, I feel like, at least as a software developer that does a lot of concurrency stuff, you can optimize to a place where the user will be able to see, you know, down the road a continuous stream.
That's the goal.
Yeah.
That's what I do want to do. It's like right now it's implemented so that it will still go in order. So like it won't say it has scanned up to block 6,000 until it's actually finished, like the gray rectangle of 6,000.
Yeah.
And that can happen after it has finished 14,000. And so it could be stuck doing the ones further behind.
Right.
And then, so right now it's actually worse on that front in
I
that
see.
it sits longer and it's so, but I do want to make that smoother, have a smoother approach there.
Interesting.
It's an important thing.
Yeah.
In the scanner for sure.
That's good.
Hi, long-time fan, first-time questioner. So you said that you do offer a batteries included network solution, though of course any user can provide their own, which I assume could be, you know, Tor, IGP, whatever. My question is if you have like 2 nodes and you want to get data from both of them, you just download data from both of them at once. Does your batteries included solution offer that or no?
It doesn't right now, but actually it is implemented in a way that is it would be much easier to implement that than the current approach does. It has a connection pool, and so in that connection pool you could easily like say, oh, I want to use these 2 nodes as my backend, and then you could then go further with it and have batteries included load balancer and all that stuff. But it's not implemented yet. But it's possible and it's simpler to do then.
And then if there's time, I have a second question. What's your favorite part of Monero-surveil?
My favorite part.
Is it the clean code?
My favorite part. I really like how the fees match Wallet 2 perfectly. That part is it's so good.
I think there's actually a PR open in Monero for solve one last edge case. I don't think we're there yet. I think that's an imperfection.
Nope, that was merged too.
Not really.
The release, yeah, we gotta go with the release. But yeah. That's actually interesting what he's referring to there. So I got he was pushing me to PR, which was, I mean, it was a fix for the Monero code. It was like a really rare, it was basically a theoretical edge case, but it was an edge case nonetheless, where in the Monero code, you would be able to distinguish a sweep from a regular transfer by the fee. So that, like, I picked up on that further from this work, and now have submitted the PR to make those to have parity on that front. And
Awesome.
so that came out of, diversity of clients. So that's
It's good stuff.
What would you say has been one of your biggest challenges working in a distributed development environment with people all over the world?
That's a good question. I've actually been remote my whole career. So I think I'm 5 to 6 years, and purely remote. I'd say the difference with Monero and those the past experiences is that it's a lot more, at least working on Monero core stuff, it's a lot more, you have to have a lot of self-initiative to find like good stuff that can move the needle forward and like be pushing forward on your own through and without a lot of direction, and it's that can be challenging, but it's also it's very rewarding because it's Monero and it's that's probably in my view one of the coolest things that exist.
And so for both our knowledge here and I guess other developers that watch this video online, what would you say is the best way to find opportunities to contribute to Monero? Obviously, it's a very large code base, like you mentioned, there is existence of tech debt wallet too, but if somebody's a developer and they want to start working on Monero, where's the best place to start?
So I'll give my experience and what I did. So first of all, I actually started working on Haven, which was a fork of Monero, and that I learned the Monero code base through that work, and so that was it was pretty daunting at first. I would say it's a not the easiest code base to get into, but when I then moved over to working on Monero, I was basically lingering in the chat channels in the IRC, in those groups, and there's Monero Dev and there is Monero Research Lab, and so I was lurking in there, and trying to see if I also reached out to Monero-only and BT-Nerd for if they had advice on things to look into, and I started looking into some of the things that they suggested, but as I sat longer in the Monero Dev group and the Monero Research Lab group and watched issues and watched how development was flowing, there were particular things that piqued my interest and that I drew to where I felt like okay, this is something I want to chase and dig into further. In particular, it was the decoy selection algorithm back then, and so that's how I got my sea legs in Monero development. I'd say it was lurking for a while, watching how development flowed, joining these groups, and today there's also the No Wallet Left Behind group, and it's tough. I won't say it's the easiest thing to break into, but I'd say that you have to have so you watch and you see issues come in. You find issues yourself, when you're using Monero. That's other ways that I've found things to do is just general running into technical issues and seeing getting to the bottom of them, or issues with the node or whatever, and just digging into them that way. So I would suggest lurking for a while, using Monero as often as you can, and then letting your whatever interest you gravitate towards that work, and then build up and chase stuff in that way. That was my path, what I did, and so that's what I'd say.
All right, thank you.
So you mentioned with the full chain membership will require a hard fork and the current wallet address format will change. And so would I be able to send coins from an old wallet to?
Yes, you would. Okay, so it would just be the receiving side. So any Monero you've received in the past is spendable forever. That's not going to change at all. And your seed will stay constant. The only thing that would change is to be able to receive Monero. After that point, you need the new address.
What would the new address look like?
So that is still an open research point. Right now, the proposal on the table is a 3 public key address, something like 150 to 200 characters in length. It's longer than the current address. And then there's a proposal on the table right now to bump that further with another public key. So
I love it. That's awesome.
So it's an open question at the moment. You can participate in the discussions and the Jantis spec that is talked about in the past before, and it's also you can find a drop in your ask if you just Google Jantis, I'm sure that would JANTIS. take part in those discussions. Yes?
So, what, like, the bulletproof stuff, that's just recently implemented, right?
Bulletproofs was implemented 2017, 2018, something like that.
So, like, this whole time, they've been just using bulletproofs for privacy,
Okay, so bulletproofs right now, as used in Monero, are for the range proof, meaning that so when you send Monero and you look up on the blockchain and you see that transaction, nobody can see the amount in that transaction. What range proofs do, where bulletproofs step in, is that they say the Monero sent in a transaction was a positive number, basically, that you were sending a positive amount of Monero within the range of 0 to the max number that is allowed. And so that's their role right now. In full chain membership proofs, I mentioned bulletproofs as well. They're multi-purpose. They can be used in different circumstances. So right now, Monero uses them for the range proof component, and then it could also be used and is used now in that full chain membership proof implementation. So
how would it be used in full chain?
it's a different internal approach. Luke could give a better, yeah, you want to give an answer on this?
All right, so I'm assuming everyone knows, the basics of cryptography, hash functions, elliptic curve cryptography, fiat Shamir transform. Don't worry, we're not going to go too far into special honest verifier zero knowledge today. No, so bulletproofs, currently they're used, as Justin said, in Monero to prove that when you're sending Monero, that you're sending 5 Monero, and not -5 Monero, and just giving yourself Monero. And when we use it to prove numbers are positive, that's not actually what bulletproofs do. Bulletproofs just prove a series of multiplications. And we can use those multiplications to prove that you're doing positive numbers. It's a whole thing. But we can also use those series of multiplications to prove arbitrary programs. Instead of proving, yep, these numbers multiply to this, and that's within our limit, we can say, yep, these numbers multiply to this godforsaken polynomial, and this polynomial somehow is some brief statement we want to be true. For example, I know something that hashes to something else. Because if you look at hash functions, that building block of cryptography, it's just a series of math equations that take an input, output a result, and you can convert that into math and use bulletproofs to prove it.
Does that answer your question?
Very succinct.
That's what I wanted to, how would it be?
Oh, bulletproofs are just proposing, Seraphis is just proposing bulletproofs for range proofs still. With full chain membership proofs, we use bulletproofs to prove a program that shows this output is one of the historical outputs.
Oh, that answers.
Cool. Thank you.
How do what's the consensus for proposals? How do they go through your process for what who decides? Is there a mono repo somewhere that people agree on what is the current
Yes.
implementation?
So we put the ideas out there, and then when Fluffy Pony says yes, then it goes. So I'd say it's a loose consensus is what the term that we use. So like I'll explain how this process is unfolding for the Jamtis address. So right now, Tevador, who also worked on RandomX and Polyseed, so they put up a gist on GitHub that lays out this new address spec that would do all these different things, and then in the comment section of that, we then have like long discussions, like getting into the different components of it. Sometimes that'll then offshoot into a separate issue, or if like quick chat forum is the better means to discuss a particular thing, then we pull it over into like the Monero Research Lab, the IRC, and this is all in public, and it's all like out there. And until like there's rough agreement and all the parties involved who are actively discussing what's like the way forward, that's essentially, I'd say, how loose consensus gets settled on. And there have been some like disagreements over like what trade-off to make on certain fronts. but we've basically been able to progress forwards to ultimately land on something that one group, our group, like the people who are generally involved in that day-to-day, seem to have a loose agreement on. So that's basically how it's flowed. Okay.
Hello everyone, I'm presenting here on Surveil again today. Presented on it a couple of times. Actually, the most recent time may have been New York. I'm not sure I presented on it since then, but there was a cake meetup in New York where I had the privilege of speaking about Surveil at Big Bear. This presentation was originally a copy and paste for it, but I tried to modernize it to kind of show why Surveil has taken so long and why it's still worth talking about after this long in development. So just as a brief premise, Surveil is a decentralized exchange for Monero, Bitcoin, and Ethereum. I always like to start my slides with who am I? Justin in their presentation already gave a bit of background on that. For me, Kayaba or Kayaba Monero-only. Luke, for anyone who prefers pronounceable names. You know, I've heard Kayaba, I've heard Kayaba, I've heard so many options. So, lead developer of Surveil. I'm also a member of the Magic Monero Fund. If you want to donate to Monero development but don't want to pay US taxes, we exist. We also have never been hacked. You know, apparently not all Monero development funding groups can say that. We know we're in a badge of honor.
Too soon, bro.
You know, Justin, you consider doing your next TCS with Austin's dad?
That's it, bro.
Oh, I actually did the first Monero atomic swap, so I've been around for a couple of years, always had an interest in decentralized exchanges and removing trust from those sort of systems. And developer of full chain membership first. So when I have the time, I do like to actually contribute directly back to Monero and not just sit over here doing all these Surveil things, which may or may not be useful. Alright, so Surveil is a decentralized exchange that aims to strike a balance between primarily user experience and security. That comes in a few different forms, which my following bullet points get to, but basically, we offer liquidity pools for immediate execution of swaps. We don't have an order book. So instead of you saying, hey, I want 10 Monero and I'll pay 1 Bitcoin, or whatever the numbers are, you're going to say, hey, I'm going to put 10 Monero into the liquidity pool. The liquidity pool might just be total garbage numbers here. It might have 100 Monero in it and 100 Bitcoin in it. If you add in 10 Monero, it's now going to have 110 Monero and 90 Bitcoin. As you add to one side of the pool, it takes from the other side of the pool. And with this, it's able to immediately serve. Okay, don't lean in. Got it?
What's that about?
If I talk from back here, all right.
It still picks you up.
Great. So it's able to immediately surface swaps. You don't have to wait around for someone to be the taker on your order book. And the notable part of it is it also enables passively providing liquidity. Instead of having to update your swap orders and say, oh, now the price has moved, I'm going to move my orders with it, the liquidity pool automatically adjusts based on the rate at which people are swapping Monero in and out. It's secured by a large-scale multi-sig maintained by validators who are staking a sufficient amount of stake to justify them holding external coins. And this is on a security premise inferior from atomic swaps. With atomic swaps, you only have to trust the maker and the taker, and you're one of those parties. Sorry, I messed that up. You don't have to trust anyone because the only people involved in it are the maker and the taker. There's no third party, and you run code that cryptographically guarantees the atomic swap either goes through in your favor or doesn't go through at all. With Surveil, there isn't really a maker and taker structure. Instead, there's you, the user, and then there's the liquidity pool, some abstract object which is managed by the multisig. So you do have to trust the multisig to do the right thing, but they're economically incentivized to do the right thing. So this does reduce the security a bit, but it tries to maximize the user experience, which my next slide covers a bit more. And then regarding flexibility, the really great thing about surveil is that validators can actually independently choose what networks they want to secure. So if we want to integrate, 10 different blockchain networks, we want to get Polygon, we want to get Solana, we want to get the 3 forks of Solana. If you're not using a terabyte of RAM, are you even a serious project in this day and age? And if we want to say all that, and you guys in the crowd are like, I just want to swap Monero. I like Monero, I don't know why you're asking me to have a terabyte of RAM. Yeah, you can run a surveil node and a Monero node and only secure Monero. You don't have to get this beefy computer, you don't have to support networks you don't want to. If you want to be a surveil validator, you can choose exactly what networks you want to secure. So why not have atomic swaps? I briefly commented we're less secure than atomic swaps because atomic swaps are effectively trustless. And honestly, atomic swaps remain great for a lot of trades. If you're doing this OTC deal, you're buying $100 million of Monero from Vic. Yeah, sure, use an atomic swap. I don't want to mess around with $100 million. The main issue is they require users to remain online for the time of the swap. So, you have to set up your offer, you have to wait around for someone to take the offer, then when someone takes it, they send you a message, you send back a message, you do the on-chain transactions, once they confirm, you do another action, and then it's over and you're welcome to repeat. Ideally, that process takes around 40 minutes. Yeah, that's a long time. You don't want users to pull out their phone, do a swap. Great, don't turn off your phone for the next 40 minutes, you lose your money. That's not a great user experience, and they also have not the best security because in order to participate in an atomic swap as someone offering atomic swaps, you have to keep the coins on a hot wallet. They always have to remain accessible. With surveil, you can argue the coins are on a hot wallet because all of the private keys are hot, but it's not like you compromise a single server. You can drink the multi-sig because it's a multi-signature wallet. You need 67% of all the validators to make any transaction from them. Theoretically, you can do something similar with atomic swaps, but no one's done so yet. And then if we actually look at existing services in the Monero ecosystem, there are a couple of atomic swap projects, but there's also Bisq. Bisq doesn't use atomic swaps most of the time, but when it does use what it is doing a Bitcoin Monero swap, its user experience is very similar to what it would be if you were doing an atomic swap. First, someone locks up the Bitcoin, then someone sends the Monero, then someone redeems the Bitcoin. So it's kind of this multi-transaction sequential flow. And despite Bisq being existing for years, I'm not trying to say it's bad, I'm just saying it hasn't gotten the value that other decentralized exchange options have gotten, which is unfortunate, and I'm not here to disagree, but it also shows why projects like surveil justify themselves. And then Commit deployed a product which is actually based off atomic swaps, and they've, I mean, over their lifetime, they might have done 50 to 100,000 in swaps. There's also the Ethereum atomic swap project in Farcaster. I don't want to be harsh, but I would be surprised if either of them got more than 20,000 each in swap value over their lifetimes. So that's a brief bit on surveil. The project really kicked into swing at the 2022 Monero-topia. At the 2022 Monero-topia, I actually approached Justin Ehrenhofer and later Vic about it. I have since heard that was the wrong decision. I should have approached Vic directly. They will say yes to anything. But it was kind of announced a few months later, and I think it's been like a year and 3 months since like the public announcement of my work on it. So the question is, what the hell have I been doing? Aren't I just building like Kraken or Trade Ochre, but like trustless? And the answer is yes, but no. So this talk kind of, now that we have the basics out of the way, it's kind of saying, there's actually a lot of tech here. It's pretty cool. It does a lot of stuff, and that's why it's taking time, but also why it's going to be great. So it starts out with our cryptography. Obviously, Monero doesn't support smart contracts. Monero doesn't support like Bitcoin script. So if you want to do a multi-sig on Monero, you have to get deep down and dirty with the math, cry yourself to sleep a few nights, actually learn what special honest verifier zero knowledge actually means, learn about the PH mirror transform, cry yourself to sleep all nights. You know, there's a lot of work. It's very professional, very elegant. So we implemented Frost, which is an efficient threshold multisig protocol for Schnorr signatures. Threshold multisig is like 5 of 10. There's 10 people in the multisig, and any 5 of them can make transactions. Surveil uses 67% as their signing threshold, and there's reasons for that specific number, but it's not worth getting into here. The main comment is it's a super majority. And then Schnorr signatures are just a type of digital signature algorithm. Monero doesn't use them. Currently we use something called CLSAG, but we can reduce CLSAG to a Schnorr signature in practice. It's multiple orders of magnitude faster than schemes for ECDSA signatures. ECDSA is standardized by the US government in the late 90s, early 2000s, used in Bitcoin, used on Ethereum. So the main reason I cry myself to sleep all those nights. It's a very complicated piece of math that only exists to avoid patents, and in doing so, it pulls in a lot of garbage and pain that just should not exist, and everyone really should just use nicer schemes like Schnorr. Schnorr exists, just use it, guys. It also, Schnorr signatures, because they're so much simpler, the schemes for producing their signatures are much simpler, and that enables a lot better security commentary. Instead of saying, oh, you have to do all this math, and you have to trust every single step of it is correct, and here's the 7 messages you have to send in this exact order to achieve security. Schnorr signatures are just much simpler to do in a multi-sig setting, and with that comes security. And then finally for Frost, it's actually undergoing standardization under the IETF, maybe technically the IRTF, but the Internet Engineering Task Force, who do a lot of web standards. And Surveil is a listed implementation of what's currently a draft, but I believe is up for final review. And we've also had our cryptography audited by CipherStat just to ensure it's secure, and we're not going to lose all the points. Actually, a lot of the auditing work was done by Aaron here. They did a great job with it. Thank you for that. And that's kind of the backbone of Surveil. The cryptography, what really underpins it. But there's a lot more to Surveil. There's also our processor, which just processes an external network, generates an event feed. If we want to, handle Bitcoin coins, actually execute swaps based on them, we need to say, hey, this Bitcoin transaction, it's actually to our key. We should do something with it. And that's what the processor's job is. It's just meant to scan Bitcoin blocks and identify transactions. And the processor also enables anyone to verify the integrity of Surveil. Anyone will be able to spin up a processor, download the, say, Bitcoin blockchain and the Surveil blockchain, and verify that the Surveil multisig did everything it was supposed to. And because it did everything it was supposed to, we haven't gotten hacked, we haven't been robbed, the validators didn't decide to turn malicious, so on and so on. And with that verifiability, effectively comes the inability to steal or misappropriate funds, and prevents me from going to jail like SBF did today. It's also designed with a minimal interaction flow to eliminate opportunities for faulty data to be injected. There's this one project known as Multi-Chain, and they actually shut down recently due to pressure from the Chinese government. It's a whole thing, it's a mess. They claim to be using multi-sig. Their CEO had all of the keys and all of the servers. That's its own discussion for another day. But one of the things multi-chain did is when you sent Ether on Ethereum to their contract, they didn't just scan the contract and say, hey, we received 1 Ether, we're supposed to bridge it to this other network. When they received 1 Ether to their contract, you then just had to send them a web request. And that web request says, hey, by the way, I sent you 1 Ether. So not only do I have no idea why they did that, I think that's a horrible design, but this introduces the opportunity for a mismatch. You can send 1 Ether, but then tell them in the event log, hey, by the way, I sent you 100 Ether. And then it becomes their job to actually check that if you tell them you sent them 100 Ether, to check you actually sent them 100 Ether. Now, Multi-Chain did check that you sent the amount you claimed to send, but fortunately I did not get a bug bounty for this. They did not have it as a bug. But these type of potential issues just don't exist if you don't have 2 sets of data. You don't want to, get data from the Bitcoin blockchain and get data from the user. You want to only have 1 source of data, and you want it to be the accurate source of data. So with Surveil, I really tried to design the system around that. It also just makes us much more efficient because instead of having to handle 2 sets of data, we only have to handle 1. We obviously can't completely eliminate potentials for faulty data, but minimization has been a focus. There's also a work in progress to exhaustively model the processor, its design. Exhaustively modeling it means literally testing every possible order of events, every possible combination of events, and in the process verifying it handles them correctly. Which means if we actually deploy it, no matter what events happen, we will always get the expected results. So that's actually a work in progress, just being a bit more formal about ensuring its security. And currently it's implemented for Bitcoin and Monero. The Bitcoin integration for the processor relies on a Bitcoin library, Bitcoin surveil. It's not as in-depth as Monero surveil, didn't re-implement all of Bitcoin, there are already libraries doing that. But Bitcoin surveil just applies our work on Frost to Bitcoin, and that has also been audited. And then we also will be integrating Ethereum. We do have Schnorr signatures verifying on Ethereum and a contract for that. It just hasn't been integrated into the processor yet. This is when it starts getting out there, and I'm sorry if I do get too technical, but let's see how it goes. We also have a thing called a tributary. Credit to Rucknium, a researcher for the Monero Research Lab, for the name. The tributary. A lot of words on the screen here. It's a micro blockchain for a verifiable broadcast layer. I'm sure you all know what that means. On a per multi-sig basis. All right. So what this means is when we're doing the signatures, all of the validators who are signing have to send each other pieces of the signature, no signature shares. So there's exploits possible if I'm doing a signature with Justin and Justin, two Justins. I don't want it where I send Justin Berman one signature and Justin Ehrenhofer another signature. Because then Berman's going to think I did one thing and Ehrenhofer's going to think I did something else. And no one's going to really agree on what I did or know what I did. So the solution is this quote-unquote verifiable broadcast layer. It says if I send a message to someone, everyone can see I sent the message, everyone agrees exactly what message I sent, and I can't have sent 2 messages, because then everyone sees I sent 2 messages and they can call me out on my shit. So verifiable broadcast layer, it just ensures that messages are being delivered properly and gives us some really nice security properties, which unfortunately a lot of other projects hand wave. They just send messages and assume we'll be fine. It's kind of fine, it's kind of not fine, but I'm happy we do it properly. We implemented it as a micro blockchain because it turns out blockchains are actually kind of good at distributing messages to everyone and getting everyone to agree on it. One of the reasons we use them. So yeah, just wrote a blockchain, called it a day. And then it's on a per multi-sig basis, which a further bullet point gets to. But yeah, offers security also means if you go offline, when you come back online, you don't have to have no idea what's going on. You just download the blocks you missed and you're caught up. And it's disposed of at the end of each multi-sig. So if we, generate 100 gigabytes of signing data, we got a lot of swaps going on, we had to make a lot of transactions, and somehow we got all the way up to 100 gigabytes of signing data, yeah, we're not going to ask everyone to keep 100 gigabytes of signature shares, which don't matter. Only the actual signatures go on the Bitcoin blockchain. The shares are irrelevant. We're not going to ask people to keep 100 gigabyte of intermediary data around forever. No, we scope it to the relevant lifetime. The signature shares are needed by that multi-sig. So as soon as that multi-sig is done, we just scope them out. And this keeps resource requirements down. It means if you only want to run a Monero validator, you don't have to deal with all of the Bitcoin signing data also on your computer. And technically, we could have used the surveil blockchain for this, but again, then everyone would have had to have a copy, which would have been stupid. Then there's the coordinator. It's not centralized. I know it sounds like it is, it's not. It's not the IOTA coordinator. It's not centralized. I'll say it again, it's not centralized, guys. Yeah.
This is not.
Is it centralized?
It sounds
Vic, you
centralized.
can leave now.
It sounds like I
It sounds centralized, Luke.
So basically, it's a local service that every validator runs, and it just coordinates the local software stack. So if you're running like a Bitcoin and a Monero processor, you're generating all the events for Bitcoin, you're generating all the events for Monero. The coordinator is just a service which handles those event streams, it handles the tributaries, the communication with the other validators, and it also communicates the results to the surveil node itself. One of the main reasons for this was actually about data isolation. When we sign a Bitcoin transaction with a multi-sig private key, that private key only exists in the processor. The processor isn't networked to anyone else. you can't say, oh, these validators have a peer-to-peer network. What if I send evil messages to extract the private key because I'm in North Korea and I can hack people over the network? Yeah, no, the processor just is not connected to the network like that. The processor only talks to the Bitcoin node, if it's a Bitcoin processor, and talks to the mailbox service. So even if you could hack people over a peer-to-peer network, you can't get to the service that has the Bitcoin private key, because the only thing that's connected to the peer-to-peer network is this coordinator, and it does not have any data access to the multi-sig private keys. You'd have to somehow completely take over the coordinator, then take over the server, and then it's a whole thing. But yeah, data isolation, making sure bad people can't get access to the right data. It does establish its own peer-to-peer network in order to communicate about signature shares. We're not just like running our own server that all the data is routed through. Nope, properly decentralized. And we also have an open issue to run it over Tor. This would let you be a validator anonymously and not reveal that, hey, you're securing Monero. Because if you are securing Monero, sure, that might make you a target to various people, and we want to respect their privacy. Finally, there's the Surveil blockchain itself. It's kind of like the big daddy of truth. It's built around Substrate, a blockchain framework in Rust that receives the events. So if we, receive 5 Bitcoin, we don't tell the Surveil blockchain, hey, here's a full Bitcoin block. It's 1 megabyte, and somewhere in it is a relevant transaction. No, we just tell the Surveil blockchain, hey, 5 Bitcoin. Here's what to do with it. It actually executes swaps. We need to agree on the order that we receive Bitcoin transactions in, and transactions happen on the Surveil network itself in order to determine what order to execute swaps in, and therefore determine how much each swap gets. So this Surveil blockchain handles all of that ordering and execution. It also hosts the native Surveil coin, which is used as stake to secure the network. Unfortunately, you can't use exogenous collateral as stake because it does not work out. There's theoretically some designs based on like clients in Ethereum, but let's just say it can't work out. It also decides the validators. It hosts the Surveil coin, and when you stake Surveil, you become qualified to become a validator. And it says, yep, here's the 150 people who stake the most Surveil to be Monero validators. These 150 people will be the Monero validators for the next week or so. Moving on, distribution and generousness, how this is actually planning to look out, which hopefully I get to talk about a lot more over the next few months. Initially, there's going to be a trusted set of validators to launch the chain and handle everything. While anyone will be able to join the validator set at any time, it's not like, hey, this is a trusted set, they're in use for the next year, deal with it. Or, oh, they're not going to be the only validators, but they're still sticking around with the super majority. No, they can be replaced at any single time. Someone just has to step up to replace them. The issue is, no one can sign up to replace them if there's no chain to sign up on. So we need to create the chain in order to let people sign up in order to replace them. They're not planned to receive any pre-mine or get any provided stake. There's no pre-mine at all in Surveil, no developer accounts get any portions. These validators aren't, so there is a minimum stake requirement to be a validator. These validators aren't going to be gifted that minimum stake requirement. They're solely planned to receive the emissions. So just as all validators are going to earn rewards in the form of the Surveil coin for their work, so will these validators. And ideally, those are developers of the project, integration partners, and just community leaders from Surveil, Monero, Bitcoin, Ethereum, and associated. If you want to participate, provide liquidity. At launch, the multi-sig will be open, and that will be a technical option. Since there's no Surveil coin yet, because we haven't done any distribution, there's no pre-mine validators, you don't get any. You would just add liquidity as Bitcoin, Monero, Ether directly. And then after a set amount of time, say 1 month, the Surveil coin will be airdropped into the pools. And you'll be able to withdraw whenever, but the Surveil will be time locked. So if you add 1 Bitcoin, and we airdrop however much Surveil into that pool to match your position, yeah, you can withdraw that 1 Bitcoin whenever, but it will forfeit the remaining amount of Surveil that has yet to be unlocked. And then that Surveil time lock will probably go for a year or so. So if you wait the full year, you get the full amount of Surveil, else you get the trickle fed over the year, and that should stop a massive sell-off because ideally, I can't really give economic advice or legal advice. Hey, Justin, you said you were my legal counsel. No, you're not my legal counsel. I have to make a few calls about that. They're mailing documents to you on Wednesday. But, but basically, the idea is basically because there's no cliffs or massive events, it's just meant to be smooth and steady. And then as a clarification, if you have one Monero, we're not like taking half your Monero and saying, oh, you converted it to Surveil. No, your liquidity position will still be one Monero, and then it will additionally be some amount of Surveil. And then when swaps happen, those ratios will change, so on and so on. This is a slide on the relationship with Monero. It's a bit interesting to have. Unfortunately, a couple projects in the Monero ecosystem were harassed by an extremely vocal minority, and I'm not here to say they're anything but a minority, I'm just acknowledging that. So, I think a year ago, I wrote a quick thread saying, hey, Sarai loves Monero, but it's not a Monero project explicitly, it's its own thing. And then recently I wrote a blog post about it, and people still had some questions, so here's the definitive answer slide on all my stances on this. Please read carefully. I really love Monero. I work on it. I'm working on this whole privacy thing, increases the privacy set 500,000x. For some reason, Berman didn't want to include that number. I think it's great. I think we should have set the percentage at 0.00018%. That's what great signatures offer in output set size. Anyways, I wrote this Monero library from scratch. You can just use it. You don't have to use any Try functionality. It's a much more efficient multisig that anyone can use with Monero. We host it and we're going to maintain it, just as kind of something for the community. Sure, it also works for Sarai, Sarai needed it, but giving back, collaboration. But yes, Sarai is not officially a Monero project. We don't wake up every day pledging allegiance to Monero. We don't, get payments from Fluffy Pony. We're not embezzling from the general fund. We probably didn't hack the CCS to use that money to fund development. It's a software project, and while we love Monero, we're connecting to Monero, we can't make decisions that are optimal for Monero. The optimal decision for Monero is 100% of the Sarai is distributed to the Monero pool. I'm sure the Monero people would love that, but we're also integrating with Bitcoin and Ethereum, and we want to get community members from Bitcoin and Ethereum, and we have to consider Bitcoin and Ethereum and not give 100% of the distribution to the Monero pool. So yeah, decisions must be optimal for everyone. We have to see what's best for the Sarai community, which is made up of the people swapping on it, the people providing liquidity, the validators, the Monero community who's using it, the Bitcoin community who's using it, the Ethereum community who's using it, and anyone who wants to join and be a part of that. That's actually it for my prepared statements. Any questions?
Network on substrate, why would you choose a public network that's existing? Who's running this blockchain node?
So 2 parts to this. First of all, we have to use a blockchain just to decide ordering. And we could have used Ethereum directly, and then we would have had to pay tens to hundreds of dollars in gas fees incredibly commonly. So then we could have used an L2. Either we could have made our own L2, or we could have built a smart contract on L2 for cheaper fees, like we could have used Arbitrum or Optimism. But then we're still paying network fees to them, and they have to pay network fees to Ethereum. So no matter what, if we weren't our own network, we'd have to be paying fees to somewhere. And it's just easier to model a lot of things and easier to guarantee your ability to handle whatever scale you need to, when you don't have to think, we have to pay thousands of dollars in fees no matter what happens, or if we increase its scale, that fee amount is going to go up, and we have to ensure not that we have enough fees to make it worth it for the Sarai people, but also that we have enough fees to make it worth it to the Ethereum people or the Arbitrum people, or whatever network we deploy on. So mainly it's just so we don't have to pay fees to other people and have to deal with the 2 economic situations colliding. As for who will be the validators, Sarai has a validator set. The Genesis validators I spoke of, they're presumably going, I don't know why they wouldn't, but presumably the Genesis validators will run validators that handle Sarai, Bitcoin, Ethereum, and Monero. But anyone can sign up to be a Sarai validator, or they can sign up to be a Monero, or Bitcoin, or Ethereum, or any combination of those. So if you don't want to deal with running a Bitcoin node, don't want to deal with running Ethereum or Monero nodes, you just want to run a Sarai node because that's all you have space for on your home server, Yeah, you can just run a surveil node and solely validate the surveil network. Any other questions?
Do you have a UI or start with?
Oh, we're integrated with Cake Wallet. You will be able to provide liquidity at launch via our trusted partners. They also have a desktop client nowadays. We're not mobile only because of that. Anyone else? Alright. Oh.
Maybe less related to Sarai, but you mentioned smart contracts in Monero. Do you see smart contracts as like an important thing for Monero to like get into, and what do you see as the future for Monero and like smart contracts and other like blockchain-based technologies?
I don't think Monero needs smart contracts. I think smart contracts open up a few paths, but I think the smart contract ecosystem is rapidly developing and fractured, and adopting any smart contract system for Monero would be in contrast with not only its ethos and goals as a currency, trying to be a simple direct transfer system, but also with the project's adoption policy. I feel like it adopts a very narrow set of tech that largely unilaterally makes sense. Like, we avoided trusted setups, but with range groups, we're not considering, defining our own random range group solutions. We try to go for what's, at the time, the optimal range group solution, because that's very clear cut. But the second you go into smart contracts, you can debate for hours about the pros and cons of various systems, and it's not just, oh, this system's slightly faster, this system's slightly smaller. It's, these systems have fundamentally different abilities in different virtual machines, so on and so on. So I don't think Monero could ever decide on a smart contract system to integrate, and I don't think it is likely to decide it ever wants one. 10 years in the future, I think there's a path where Monero looks very different than it does today, where maybe part of it gets some scripting, but that's way out in the future. One other thing to consider is, theoretically, Aaron Hoffer's going to hate me for bringing this up, but theoretically, if you move Monero into the Sarai network, which we just simply call Sarai Monero, just to keep it simple and clarify, it's Monero on the Sarai network. Theoretically, if we added smart contracts to Sarai, you could use Sarai Monero and Sarai contracts. Theoretically, we could bridge the Sarai Monero to Ethereum to let you use Monero and Ethereum contracts. Unfortunately, the economics of that don't really line up. Like, we would have to charge a fee on the bridged Monero, so you might like bridge one Sarai Monero, and then on Ethereum get one Sarai Monero, and a week later it's 0.99, and a week later it's 0.98, and then a week later we would slowly take a fee to justify our economy. So then it becomes decaying Sarai Monero, DSRI XMR. But then a lot of smart contracts don't like it when the numbers change. So then we wrap it into something which is stable in amount, but redeemable for a variable amount of DSRI XMR. So now we have WD SRI XMR, and then just to really streamline it, we're announcing WD40 SRI XMR. So as you can see, the future of Monero finance with smart contracts is very great, very efficient, and very logical. WD40 SRI XMR. Aaron Hoffer will give you the rest of the details. Talk to them about it.
The future is bright.
Exactly. So no, that's not planned, but theoretically someone could do that with Monero if they want to deal with the economic bullshit behind it.
That's awesome.
Great.
Thanks.
Thank you, Luke.